Hi guys, welcome back. Hope all of you are doing good. Hope you are safe. So, welcome to the 7th session of the bridge course or the introductory course. My name is Adil Khan. I'm your chemistry teacher in Base Education Private Services Private Limited. So, today we have to discuss the seventh session. Before that, I will be giving you the answers of the previous, that is the 6th session homework or home assignment. So 3 questions I have given you. This is your question number 1, this is your question number 2, and this is question number 3. So first question was, you need to find out X, that what is X basically here is. So I hope all of you have got aluminium hydroxide, AlOH whole thrice. So X is nothing but this. Now, no need to balance and all at this point of time because balancing I have not done. The coming session is about balancing, so we will see there. So aluminium hydroxide you will get. The next question was that this reaction is an example of which type of reaction. Out of the 4 reactions which I have discussed yesterday, this reaction falls under which category? So when you see here, chromium is going and taking the place of iron. So chromium is taking place and iron is coming out. So this is nothing but your displacement reaction, which you can call it as single displacement reaction also. But the answer is displacement reaction. So if you write single displacement reaction, the answer will be again right. Third question is that this potassium chlorate KClO3, this belong to which type of reaction? The reaction we have discussed. So this reaction takes place in the presence of the heat and it breaks into 2 components, that is KCl and oxygen. So this compound break into a simpler compound and or you can tell a molecule, and again oxygen as molecule, which is basically made up of 2 oxygen elements. So you can tell compound and element. So this is an example of your decomposition reaction. So decomposition reaction, if you remember yesterday we have done that when suppose you have AB and it break into A plus B, it is known as decomposition reaction. Now A and B both can be element, both can be a compound, or one element, one compound, irrespective. There are various conditions to do decomposition reaction. Either you can apply heat or you can apply current, current is I, or you can apply sunlight, that is H nu. So thermal decomposition, electrolytic, and you had photolysis or photolytic decomposition reaction fall under the same category. So that's all from the previous session. I hope this is clear, and let's move to the fresh session for today. That is the session number 5, session number your 7. So whenever you see this, I'll tell you which session it is, but first tell me what I'm going to do. So this is the most common thing which you see in your chemistry lab when you come to us. We will show this in our labs also. So when you see this, so there is a conical flask. This is a conical flask. This is also a conical flask. This is a beaker. This is the glass rod which is present there. And you see that a light green color solution is there. And this is dark green, and this is purple or black color. And some fumes are there on the top. Basically, this is nothing but your solid carbon dioxide. Generally, this graphic image was suited using solid carbon dioxide, that is dry ice. So whenever you see this, and what do you think? What first thing strike in your mind? Strike chemistry lab. And after that, what strike? That some reaction is taking place, right? So you're right. So some reactions are going on. That's why the fumes are coming up and all. So today's session, that is session number 7, we are going to discuss about writing of chemical equation. So 2 part I have divided the session again. Writing of chemical equation, and what is chemical equation I will tell you and all. And that then balancing of chemical equation with the question of the day. Okay. So session number 7, writing of chemical equation. So I have already told you what is a chemical reaction. So chemical reactions are represented by chemical equation. Chemical equation, basically what it is a shorthand representation. Short means in the much shorter, crisp form. A chemical equation is a shorthand representation of a chemical reaction using the symbol of the elements and the formula of the compound involved in the chemical reaction. In short, you can tell that it is a symbolic representation of a reaction. It is a symbolic representation of a reaction. First time the concept of chemical equation was given in the year 1615 by a French chemist. His name was Jean Beguin. So 1615, this equation was given, chemical equation concept was given for the first time by French chemist Jean Beguin. Basically, what is chemical reaction and chemical equation? Chemical reaction can be represented by chemical equation. Chemical reaction can be represented by chemical equation. So what is chemical equation? Basically, there will be a reactant, there will be a product with some conditions. Suppose reactant I represent as R and product I represent as P. So when you show the reaction is like this. So reactant becoming product. Various conditions are there. So that conditions and all we will see in our further future classes and all. So the substance at the start of the process or a start of the reaction is known as reactant. So this is I am talking about. In a layman term, if I want to give you this example, understand this. For example, you take rice before boiling, then it is known as your reactant. And after you boil it and the rice is ready, the boiled rice is ready, when you remove the starch and all, it is known as product. So unboiled, uncooked rice and boiled and cooked rice, this is reactant and this is product. Condition was what? Heat you have supplied in the presence of water. So this is an example of your reaction, which you can keep in mind. Or suppose you are preparing pizza. Then pizza, you will have the base and you will add all the toppings. You will add cheese. You will add the sausages, mayonnaise, whatever you feel like you will add. Whatever toppings you need to add, you will add that and put into the oven. Before putting into oven, it was all reactant. It is raw. After putting into oven, the heat which is given by the microwave to the uncooked pizza so that it become baked completely, and what you take it out after a couple of minutes and eat, that is the product. So uncooked and cooked condition is temperature or the heat. So before reaction is known as reactant, after reaction is known as product. So the substance at the start of the process is known as reactant, and the substance formed after the process are known as product. Generally, the products are more in demand and they are more stable when you compare to reactant. So when I will teach you the stability, I will tell you what you mean by stability. By stability. So in a chemical equation, the reactant are written on the left hand side. This is convention. Okay. You have to write the reactant on the left hand side. So this is your LHS, and the product is written on the right hand side. This is RHS. This is convention. But when you go to higher classes and all, you do your masters and PhD, you can write anyway because you know much of chemistry at that point of time. Since you are fresher and you are starting your journey of chemistry with us, so please follow the convention. And reactant and product, LHS and RHS, is separated by an arrow. This arrow is known as yield. Okay, it has a name known as yield. Basically what it tells us about the direction of reaction, that which direction the reaction is moving, from reactant side to product side and vice versa also sometime. So the arrowhead is pointed towards the product and the tail is towards the reactant. So this is nothing but the head of the arrow and this is nothing but the tail of the arrow. Okay, in physics you have that vectors and all, don't get confused with that part. So in general, chemical reaction we represent like this. I have given you R and P. Here it is more precise, A plus B giving C and D. So A and B are reactant and C and D are your products, and the steps involved in writing chemical equation is coming next. Now before that, I want to give you some extra content so that you know a chemical reaction much in a better form. First is I have divided this part into 4 sequences. First, I'm going to talk about movement. Okay, and the arrow basically. Suppose this is a reactant and this is product. So if I write like this, it means that the reaction is unidirectional. It is moving in one direction. So when it moves from reactant to product, then we called it as, it is as forward reaction. or we called it as in forward direction. Okay. Now suppose this is reactant and this is product, and I write like this, then this is backward reaction or backward direction. Or even I can write like this. When you write like this, it means that reaction is moving in both forward direction, and the reaction is moving both in even in the backward direction. So forward direction and backward direction, the reaction is moving. And when I write reactant and product like this, and I write single-headed arrow, then this tells that the reaction is at equilibrium. So equilibrium at this point of time, you just know it is nothing but balance. In your school, you would have saw the seesaw. Seesaw, you remember this, no? So if one person is heavy, it is down and it is up. Now, when a situation comes when you balance like this so that it is on equal level, this is known as equilibrium. So this represents chemical equilibrium of the reaction, that the rate of forward and backward reaction is same. Now, generally, many books write these to be same, but they have a slight difference between them. So you remember that the arrow can be in forward direction, it can be in backward direction, it can be both forward and backward, and it can be equilibrium. So reaction can be represented like this also in future. So you just keep this in mind. Sometime you will also see that our reaction is written like this. It means that the rate of forward reaction, the speed at which reaction is moving in forward direction is more than that of the backward direction. Reverse is also possible. So this also tells that, okay? For example, in layman term, if reactant to product, it is taking in reactant to product, if suppose you start with 1 kg of this, then reactant to product, suppose you get 700 gram of this, then backward direction, you will again get back 300 grams. So how much product is produced? It is more than that what reactant is produced in the vice versa format. So this means that product is more produced and reactant is produced in the less amount. Got it now? Good. So this is with respect to the movement of the arrows, which I would wanted to explain you. Second is I am talking about physical state. Physical state, you know, which you can see basically. So for physical state, we write solid as small s in bracket. Then for gases, we write small g, and for liquid, we write small l. And there is one more state known as aqueous when water is there. So we represent like this. So they are the physical states. So basically, you write the physical state on the bottom right side, okay? Bottom right side, or which you can call it as subscript. For example, if I have a reaction like A plus B giving me AB. Suppose this is solid, so I will write it as solid. Suppose this is aqueous, I write it as aqueous. And suppose it is aqueous, I write it as aqueous again. If it was gas, I will write gas. And if it is liquid, I will write liquid. So the physical states are written on bottom right hand side. With experience and with our classes, you will get to know that which reaction is in which state and all. I'm not going much in depth here, okay? Now, sometime what we see that some reactions are there. Suppose I have a reaction known as X plus Y, and I get Z, and suppose I get B. And in this reaction, if suppose Z is the precipitate means it is insoluble. So how to know precipitate? You take a beaker and take cotton, small piece of cotton, and drop into that. It will absorb water and settle down. It is not soluble in water. Then it is known as precipitate, okay, which you short known as PPT. In 10th standard, you would have done. So precipitate is represented by downward arrow. This is the symbol of precipitate. And suppose if B is the gas, so either you write G or you show the upward arrow. Upward arrow you show when the gas is evolved, when gas is coming out of the beaker or test tube in which you are doing the reaction. So downward arrow represent PPT or precipitate, which is not soluble in the water or solvent you have used. And this represent evolution of gas that is coming out of the gas. So this is the physical state, what I wanted to discuss with you. Third what I want to discuss you in this part is, this is nothing but your energy content, which is known as energetic. Suppose I have a reactant which is giving product. Generally, reactant doesn't give product. You take rice and put into unboiled or uncooked rice, if you take and put into water and leave it until that you boil up on yourself, it is not possible. You need to give heat from outside. So that heat is represented by the Greek, this is the Greek symbol. So this represents basically your heat. It is known as delta, Greek symbol. Sometime in few reaction where you have reactant and product and sunlight is used, so there you write it as H nu. So H nu is nothing but it represents light. Basically, it represents energy of photon. Photon is light, so you can write like that. So energies can be represented by delta. It is written on top of the arrow. Okay, so remember that part also, and even the sunlight what you have. One more thing, last thing which you need to know here is there are two type of reactions. Okay, chemical equations are of two type. One is your molecular equation. So in today's class, I will be basically doing molecular equation, and there is something known as ionic equation. Okay. So ionic equation, I will just give you a brief example about it so that you know this. Today we are going to discuss this you understand what is ionic equation. For example, if I take sodium chloride and I add it into water. Okay. Suppose I add it into water, it is known as NaCl aqueous then it is split as Na plus and Cl minus, and Na plus aqueous and Cl minus aqueous. So this is known as cation, sodium cation, and this is your chlorine anion. So this is known as ionic equation, where you write either product or reactant or both side in the form of ions. Ions can be either present on the reactant side or product side or on both the side at this point of time for you. So this is an example of your ionic reaction. So I hope that is clear. So 4 extra thing I have done, which is not there in the slide. First, I have done the movement, the arrow one. Second, I have done the physical state, then energy, and then a bit of ionic equation. I hope that is clear to you. Okay. So basically, again, a chemical reaction is represented by your chemical equation, and chemical equation is a shorthand representation of that. Let's move to the next slide. The next slide tells the steps to write chemical equation. If you remember this, so the steps involved in writing chemical equations are given below. So the first step is write the word form of the equation. So word form is generally written, for example, zinc reacting with hydrochloric acid, giving zinc chloride and hydrogen. Basically, it is a gas, because you know that metal and acid react to give salt and hydrogen gas in your 10th standard. So you would have done metal when it react with basically mineral acid. So it give you salt, and with salt it give you hydrogen as gas which comes out. Second, a sign of plus is added in between the formulas of reactant and also between the formula of product. So you had zinc and hydrochloric acid, zinc chloride and hydrogen. So you need to add plus. This tells that this with this. So this with this is present. Step 3, symbol is represented for the gaseous state, which I have discussed, and down for the precipitate. Those are the extra thing I have given. That is solid also you can write, liquid also you can write, gas also you can write, and aqueous also you can write. Upward arrow basically you will use when there's the evolution, means coming out, gas is coming out of the system. If you give inside, then you write G. Okay, that is convention we follow for your level at this point. And step 4, the skeletal equation is balanced. So balancing I will teach you by hit and trial method. Most of you also know, it will be a revision for you. So that's all which is here. So balancing, if I show you for above reaction, so you have zinc, and when you treat with HCl, so I'm writing it like this. So you can write the arrows like this also, okay? So ZnCl2 and your hydrogen gas. But preferably you keep a standing line, a sleeping line for that. So zinc is 1, here 2 chlorine, so you make it 2 and 2 hydrogen. So this is part is balanced. everything is balanced. If state I would mention, zinc is solid and HCl will be in water, so aqueous. This will be again aqueous, and its hydrogen is coming out, so forward arrow, upward arrow. So this is the balanced equation. This is the reaction between zinc and hydrochloric acid. Let's see a couple of example more. The reaction between magnesium metal and sulfuric acid to give magnesium sulfate and hydrogen. Before that, I would give you a simple reaction and explain the various component there. For example, if I write formation of water, so oxygen and hydrogen when I write, and then I write 2H2O in the form of the, now I need to balance it. So to balancing, I am writing 2 here and 2 is here. This is basically in the gas form. This is basically in the gas form, and this is basically in the, initially it will be in the gaseous form and then it will be condensed into the liquid, initially gas only. So this 2, what is there, it represents hashtag means number, it represents number of atoms what you use basically, or number of reactants what you are using. So number of hydrogen molecule, how many you are using, 2 times. And here if it is nothing written, it is understood that this is 1. This represents state of the substance or state of matter. This is a matter. And this side is nothing but your reactant side, and this side is nothing but your product side. Remember that reactant is also called as substrate. Here onwards, it is also called it as substrate. And this arrow represent yield and the direction of the reaction. This 2 is also known as coefficient. Basically this 2, 3, 4, whatever number you use, it is help to balance the equation. This is also known as coefficient. And this part what you are writing, this is nothing but it is also known as chemical formula. So this is your chemical formula of your product. So a reaction is made up of various things like this. So if you see, it is made up of various things. It is made up of reactant and substrate, which is here. It is made up of product. Then it is made up of how many number of reactant you have used, state of matter, then yield. If any condition is required, suppose this reaction take place in the presence of something known as catalyst and temperature and pressure, that also you have to show. This is a coefficient which help to balance the reaction. And this is the chemical formula of water what you have used. So basically our reaction in general look like this. The reactant will be there, product will be there, yield or direction, physical state, various conditions you need to mention, and the coefficient must be there. So a reaction consists of these all things whenever you write it. So moving to example, that reaction between magnesium and magnesium metal and sulfuric acid to give magnesium sulfate and hydrogen. So I will not write step by step. I will write entire thing at a short and then balance it. Pause it and you people write it first. Do it now. I hope that is done. So I will be writing magnesium, and magnesium when you treat with sulfuric acid, it is king of acids, or you can call it as king of chemical. So what you get, magnesium sulfate. So MgSO4, and you get hydrogen as the gas. So balancing, you see 1 magnesium, 1 magnesium, 1 SO4, 1 SO4, 2 hydrogen, 2 hydrogen. If you feel like writing state, basically metals are in solid, acids are in the aqueous form, the salt produces in the aqueous form, and the gas, this is gas, so you can write it as upward arrow. So basically this is the reaction, you write it. One more you try, a reaction with sodium chloride and silver nitrate to give silver chloride and sodium nitrate. Pause the video and solve it now. Okay, so sodium chloride, I am writing NaCl, and this will be in your aqueous form because you cannot take salt and put on something until unless there is a heat or water. And then you have silver nitrate. Silver nitrate is also in the aqueous form. Basically, it is a salt. When you add to water, it becomes aqueous. So they will interchange. So you get silver chloride. With silver chloride, you get NaNO3. Now this silver chloride is the white color precipitate. So this is a precipitate which is white in color, and sodium nitrate is again aqueous. So basically this is nothing but your double displacement reaction, and this is nothing but your single displacement reaction, what we have done till now. Okay. So this is the way you write the reaction. This is the way you mention the state and the formula. I hope you got the clear concept about where to write reactant, where to write product, and what is the significance of this arrow and all. Let's move to the next. No, before moving to next, let me give you a couple of examples so that you can solve it. Now, can you write a reaction? Chalo, right. Can you write a reaction between glucose in the presence of oxygen to give water and carbon dioxide? Glucose in the presence of oxygen to give carbon dioxide and water. Which reaction is this, by the way? Photosynthesis. That's right. So this is nothing but photosynthesis. So please write it down. Glucose is what? C6H12O6. Then you have oxygen, that is O2. It will be giving carbon dioxide and water with energy and all, which we use in our body. Balancing 6O2, 6CO2, and 6 molecule of water. State of glucose will be solid. This will be in the gas form. This will be in the gas form. And basically this is liquid form. Balancing is done. State is mentioned. And photosynthesis equation is done. Very good. One more you do it. Now chalo, jaldi karo. Write a question. Write the chemical equation when phosphoric acid react with caustic potash. Phosphoric acid react with caustic potash. Caustic potash is what? KOH, na? Yes or no? Yeah. So when phosphoric acid react with caustic potash, phosphoric acid formula I'm giving you, it is H3PO4. Last class also I have told, last session, and KOH. Predict the product, guys. Predict. So the product will be K3PO4 plus your water. Balancing, now you tell. Balancing, now you tell. How to balance this? Balancing we are going to see in the next segment. So from there you will balance it. Okay. I'm telling you the state. So this will be a homework. So this will be aqueous. This will be aqueous. This will be aqueous. And this will be in water. So liquid form. Balancing we are going to do soon. Some 3 KOH and all you have to use. So balance it. This equation I have written, balancing will be your job. Okay. Very good. Let's move to the next. So next we are going to do a balancing of equation. So balancing, you know what? Suppose you go to market to buy something. Suppose this is the weighing balance. Suppose mango season is there, you try to go and buy mango. So when you go to market and the shopkeeper keep that 1 kg iron bar here and your mangoes here. If this is standing position, it is known as balanced. If suppose this is down and this is up, it is unbalanced, or vice versa. So balancing means what? Your left side and right hand side must be equal. So here also the number of reactant and product must be equal. So balancing of chemical equation is based on LOCM. LOCM is law of conservation of mass. What is that law? That you cannot create mass, neither you can destroy mass, but you can convert from one form to another. Okay. So the law of conservation of mass tells that mass can neither be created nor destroyed, but can be transferred from one form to another. For example, if I have 1 kg of brick here, I can break it into 500 grams. That can be further broken down into 250 gram. That can be further broken down into 125 gram each. But at the end, when you add everything, this part and that part is remaining same. This is law of conservation of mass. Or law of conservation of mass, you can understand like this. Suppose I take half kg rice and I take half kg curd. Mix both of them, you get curd rice. How much curd rice you will get? 1 kg. Half plus half is giving 1. So this is law of conservation of mass. The amount of reactant what you use must be equal to the amount of product. So balancing of equation is based on LOCM, law of conservation of mass. Please remember here onwards. According to this law, total mass of the reactant must be equal to total mass of the product. So if suppose this is my reactant giving product, so my mass of the reactant, total mass, must be equal to the total mass of the product. समझ में आया? Good. In other words, the number of atom of each kind should be equal on either side of the equation. That we are going to see. Just have patience. Such an equation is called as balanced chemical equation. Balanced means number of atoms are balanced, or number of ions, whatever you have. Ions, you leave it now. Number of atoms are balanced. Chemical equation means you use some formulas and all, what I have explained in the first part of this session. So balancing of equation is done by basically hit and trial method or inspection. You just see and balance it. So there are various methods. In 10th standard, you would have read about hit and trial method. When you come to redox chemistry, redox reaction chapter, we will teach you 2 more methods there. That is oxidation number method and ion electron method. Basically, it is for ionic type of reaction. But molecular reaction also you can use it. Basically your oxidation number wala part. So this is illustrated in the following example. So let's go back. So remember, balancing means what? The number of reactant and number of product must be same. The number of atom this side and that side must be same based on law of conservation of mass, which tells you cannot create mass, you cannot destroy mass, but you can convert from one form to another. Okay? For example, you take a wooden block. Using this, you make door. So one wooden block, you can make, suppose, 2 door. So the mass of this and the mass of this must be same. It cannot be lost. If it is lost, it will be lying somewhere as a waste product. You cannot destroy the mass easily. That's not possible. Okay? Let's move, my dear friend. So example. So nitrogen combined with hydrogen to form ammonia. Okay, nice. Just remember that production of ammonia is a name reaction. This is known as Haber's process. So Haber was basically, Haber was a German, and during World War time, he has produced this ammonia. So nitrogen combined with hydrogen to give ammonia. So nitrogen you take hydrogen, and ammonia formula is NH3. Wherever, whether you are in Germany or Russia or India or Uganda, ammonia means NH3. Now how to balance this? Here you have 1 nitrogen, here you have 1 hydrogen, but here you have 1 nitrogen and 3 hydrogen. So you need to balance. So you keep it 1 nitrogen, that is total, here I'm showing like this, N2, 3H2, I'm showing in the balance form only. So here when you see, you have 2 nitrogen, you have 6 hydrogen, and here when you see, you have 2 nitrogen and you have 6 hydrogen. So this is known as balanced form. When you see the unbalanced form, that is N2 and H2 giving NH3. So here you have 2 nitrogen and 2 hydrogen, but here you have 1 nitrogen and 3 hydrogen. This is known as not balanced. So by permutation, combination, and hit and trial method, this is the balanced form. Same thing. This is not that easy to produce ammonia. You will read later that some catalyst is required, and temperature, pressure is required, and blah, blah, blah. Haber's process. Example 2, a warmed aluminium powder is sprinkled in a jar of chlorine. You can go on YouTube and see this. This is very, this video is shown that how they react. Aluminium burned with flashes of light. Flashes of light means just like lighter, the way it burn. You would have done the magnesium ribbon experiment similar to that. Aluminium chloride is formed as the product. So aluminium and chlorine giving aluminium chloride. So I'm writing aluminium unbalanced and then chlorine and giving aluminium chloride. So I have already done that. Aluminium valency is 3 plus 3 because it is 283. It loses 3 electron. The moment it loses 3 electron, it becomes 3 positive charge. And I also told you that chlorine is 287. It is not stable again. It will gain 1 electron to become 288 and Cl minus. 3 and 1. So that's why AlCl3. Now here when you see you have 1 aluminium, 2 chlorine, and product side you have 1 aluminium and 3 chlorine. It is not balanced. How to balance? You will do the hit and trial method. So aluminium, chlorine giving your aluminium chloride, AlCl3. So I will make it 2. When I make it 2, it will be 2. Now hydrogen chlorine becomes 6. So I will make it 3. Now it is balanced. So 2 aluminium this side, 6 chlorine this side, 2 aluminium on product side, and 6 chlorine on product side. Everything is balanced. So this is hit and trial method to balance the stuff. So please remember that, how to balance it. It's not that easy. It is easy. It's not that difficult. It is easy. Only you need to do the practice. Okay, I'm giving you a couple of molecules now. You need to balance that. Okay. Can you do a reaction between methane? Methane is CH4 and heat it to burn in the presence of oxygen. Always remember, whenever an organic compound is burned, organic compound means hydrocarbon, which has carbon and hydrogen. It will give carbon dioxide and water vapor. Can you balance it, my dear friend? Pause the video and balance it. I'm waiting for you. Now here you see 1 carbon, 4 hydrogen, here 2 hydrogen, here 2 oxygen, and here 3 oxygen. So balancing you need to do accordingly. Do it fast. So if I do like this, it is balanced. Check. 1 carbon, 4 hydrogen, 4 oxygen, 2 here and 2 here, 4 oxygen, balanced. Good. This is known as combustion of methane. One more I am giving you. Now you write the formula by yourself. No, you can't write. Suppose I give you iron oxide, Fe2O3, and treat with carbon. When I do this, I will get Fe and I will get carbon dioxide gas. Can you balance it? Do it fast. So 2 iron, 1 iron, unbalanced form, 3 oxygen, 2 oxygen, 1 carbon, balance it now. Good. So this is 2. So it becomes 4 Fe. Yes or no? Carbon is how many? Carbon is 1. So you will be making it as 3 and 3. So 4, 6 oxygen, 3 carbon, balanced. Very, very good. 4 iron, 6 oxygen, because 2 into 3 is 6 oxygen. So here 3 into 2 is 6 oxygen, 3 carbon. I hope that is clear. Very good. Okay, let's let me give you a few more. You need to balance it fast. Pause the video and balance it. Balance the following chemical equation by hit and trial method. First one I have already done, that is zinc plus 2HCl. It is giving you zinc chloride and hydrogen, right? Second one, pause it and try it. Pause it and try it. So 1, 3 and 1, 3. So 1 chlorine, 1 iron, 3 chlorine, 6 hydrogen, 3 oxygen, balance. Next one, H2SO4 and NaOH, giving Na2SO4 and water. This is liquid. Do it fast. So H2SO4 reacting with 2 NaOH. Check whether it is balanced or not. So 4 hydrogen, 4 to 6 hydrogen is there. So this will be 3. So 4 hydrogen here, 4 hydrogen there, and here you have SO4, 2. Then it must be some trap in it. Try it fast. This is 2 and this is 2. 4, SO4, SO4, 2, 2. That's it. Balanced or not? Okay. Keep trying. Okay. So that part is done now. Let's move to the next. It is done. 4, 4, SO4, SO4, 2Na, 2Na, and oxygen is 2, oxygen is 2. Next one, C2H5 and KOH. C2H5Br, this is bromoethane and KOH. So 2 carbon, 2 carbon, 5 hydrogen, 5 hydrogen, Br, Br, 1K, 1K, 1OH, 1OH. It's already balanced. Next one, zinc and lead chloride balancing. So zinc 1, 2 chlorine, 2 chlorine, lead and lead. It is balanced. This 2 was just to check you whether you approach or not. So I hope that part is also done for you. Good. So just like third one, you struggled. There will be many equations you will struggle in future, but with time and practice, you will overcome that. So these are the question of the day. So you will be doing a reaction between HCl and MnO2, Fe. I believe the second one I have done, but still you do it. Carbon dioxide and S8. S8 is sulfur. P4 is phosphorus and oxygen, and V2O5 is vanadium pentaoxide. No need to know the element at this point of time. What is V? You just balance and tell me whether balancing is possible or not. So we will see this in the next class before we take the session number 8. So that's all from my side today. So today's session, what we have done the 3 questions of the previous session. Then we have done what is chemical equation, what do you mean by reactant and product, and how to represent and all, basically chemical reaction. Then we have done balancing by hit and trial method. So keep on practicing balancing. It will help. I know that at this point of time, some of you are still struggling because you don't know many elements and the formula of many molecules. But trust me, with time, we will train you that within 5 to 6 months, you will be full-fledged, ready in balancing. So that's all from my side. So take care and study well. Respect your parents. Bye-bye. Take care.